Okay, so in this second video, we're going to do a lot of the prep work for the board, but some of that prep work has to happen in the schematic side, not on the board side. So we're still in the schematic, but the work we're doing is specifically to set us up for success for laying out the board. So the first thing you're going to want to do is delete, once your schematic is done, is to delete everything that you're not going to use. So I had 3 schematics that I built in the last video's example, but for the board layout, I'm not going to show all of them. That would be insane. Can't lay them all out into one board. So I'm just going to delete these ones here. And then also I have these op amps down here that I didn't apparently delete in the last video. Once you've replaced those op amps, into Cohese, I guess maybe it is worth waiting for a second to delete the op amps. Here's what I would recommend doing. So can you guys look on my screen? How many op amp symbols do you see on my screen? 2, but I should have 1 chip because they're a dual. Does that make sense? So when I switch over to my board, which I'm going to have to slide over there, I should only find on here 1 chip, which there's none there. Oh, I see these ones. These are the empty ones. There we go. There's my 1 chip. And if I delete the others, it should then go and remove all those extra ones. So I'm just making sure I'm checking, double checking all this stuff here. Okay. And now if I just double check here, whoops, other way. There's my 1 chip. All the other ones are gone. I'm good. Okay. Now. Okay, the next thing you're going to have to decide is whether or not your module, what kind of resistors your module is going to use. Are you going to use the really small 1/8 watt ones? Those would only be for complex pedals, things like a phaser or a chorus, or maybe if you had the delay and the modulation, or the delay by itself might be a lot. Things like that, or you just layered a bunch of modules together, and so you added a lot of complexity, and so you need to shrink the size of the resistors so you have enough space. However, unless you're doing one of those more complex ones, you should be using the 1/4 watt because they're just easier to build with. Okay. And so down in this area right here, it says effect pedal template parts, do not delete. Do you guys see this right here? This is 1/4 watt, that's the larger size, that's 1/8 watt. Okay. The reason why they are there is to help you replace any ones that you have that are different. But you won't know which ones are which. You have to go to the board side. So everyone switch to your board. And it might be helpful, and I'm going to do this right here, to start grouping these parts and moving them close together so they're not all way over the place. Because remember, when we started, it was this massive amount of components spread all apart there. And so if you drag them closer together, okay. And I'm even going to drag these ones over. Well, I'll leave them there. Okay, so you can see these are 1/4 watt. They're the larger style. I've got 1/4 watt there, 1/4 watt there. But then this one right here, this one is too small. Okay. So if I want to replace it, I'm going to show you how to do this. I'm going to do it slowly. You ready? Right click on the part and then find the word replace. So I right click on the part, I find the word replace. Okay. And then I got to know what folder to go into. And so for us, that's the RCL folder. So I'm going to scroll down to the letters RCL. And when I open that up, which one is our resistor going to be in? What letter is for resistor? R. What country are we in? US. So RUS. And then the 1/4 watt one is the one that's the -7. It's the 3rd one down. And the 1/8 watt, the smaller one, is the 2nd one. It's the -5. So I want it to be 1/4 watt. I'm going to hit OK. And then that resistor changes into that larger one. And so what I'm going to do is I'm going to see, oh, here's another small one. I'm going to go right click replace. And what's nice is it'll load that same part again. Like I don't have to go find it again. And I just hit enter. And I'm going to change all my things into that larger size. Okay. There is another way that you could do it, but I find that like we could use these parts to do that. But I find that it's just easier to right click replace. Now I'm going to delete these resistors. I don't need them anymore. This is if you needed to add a trim pot, but if you don't need to, that gets deleted. My circuit doesn't have any switches, so I'm going to delete those. Okay. All right, I'm going to wrap things up here in just a moment. It looks like I randomly have this part. What is that supposed to be? A250K, interesting. Okay, where's my A250K? Oh, right there. Okay, I'm almost done here. This is from the last video. I'm going to pause right here. I just need to replace the spot. Okay, so the next thing is something that you are not required to do. Boy, is it going to save you a lot of time. Sometimes taking a little extra time will save you a lot of time. Okay, and that is because solving the puzzle of where to put all the parts is a complex puzzle that, unless you've had a ton of experience and know-how, like you'll make mistakes that'll end up having to be undone and start all over, and it's really just complicated. So here's the process that I'm going to highly recommend you do. So first, go to your schematic. We're going to go over to our schematic here, and we're going to click the layers function right here, layers. Okay. The only layers I need to see, okay, I can click hide from here. Only ones I need to see are the wires, which is called nets, the symbols, which is the red parts, and the names, because everything has a unique name. Okay. And then I'm going to coach you through this. I'm going to kind of give you this as an example here. I want you to identify in your schematic at most 10 separate mini sections. So I'm going to zoom in here. Oops, come on. Right, I'm in the right spot, right? Yeah, okay. Okay, so do you guys see this part that starts with R5, and then there's R4, and then all of this stuff, and then it ends in the chip? But it's all kind of connected in one line together. Do you see that? So I would call that like a mini section of my circuit. It's all these parts that are all like, should be close together on my board. And then if I look down here, and I look here, I call this a mini section because all of these parts are kind of combined together, all the wiring's going between each other. And then after the chip, I've got like this mini section right here. And maybe I can even include it going into the next chip, like from here all the way to there, like this whole mini section. And then after the chip, there's another mini section. Okay? Did you guys follow the logic? Okay. I want you to count up how many mini sections you're going to like classify. So for me, that's 1, 2, 3, because that's kind of like a big mini section. 4. That's it. Up to 10. Hopefully you don't have more than 10 mini sections, but up to 10. Okay, so the technique that I'm going to have you do is start at the last one, and actually use numbers to indicate that you're in that section. And I think the best way to do this is, so this is my section 4. I have 4 sections. I'm going to click on this, and I'm going to call this resistor R4 as in section 4, and it's the only resistor, so R41. Wait, R41 already exists somewhere else? Wow, that's unlucky. It's right there. Okay. Let me just call this R30. Okay. In general, that won't happen, but if it does, you can find the one that it's somewhere else. So R41, it's my resistor in section 4, and it's the only one. Okay. This is a potentiometer. So letter P, 4, it's the only one. This is a capacitor, letter C, 4, the only one in there. And so I've labeled this section. So now I go to the third section here, and this one might be R31, first resistor. This is a second resistor, so I'm going to call it R32. ESIS, you can pay attention here. This is a capacitor, C31. Here's another one, C32. And then C33. Okay, and then I've got some diodes. Oh, and a potentiometer. So P31, D31, D32, D33, and D34. So I'm essentially naming everything in each section to have the same first number, but it has to be a different second number because you can't have two things having the same name. Okay? And I'm just going to do that through all the sections. So here everything's going to be R2 something or P2 something, like it's all going to be that. And then the first one will be the first section. So I'm going to pause the video here. Go ahead and rename your sections so that you can tell what part is from which section just by what number is first. Okay? Okay, our next step of setup has to go on the board side. So I got to slide over to the board. I'm going to go up to Tools, Design Rule Check, and this is where I'm going to tell you what parameters we're going to use to make sure that everything lays out correctly for manufacturing. So first, on the Layers tab, by default, I think it allows up to 4 layers. Is that what it's showing for you guys? Okay, so I'm going to tell you right now, it allows up to 4. You should only use 2 unless you get authorization from me to use those middle layers. The reason is the difference in price between 2 layers and 4 layers is $5 to $20. So you can't just, okay, it makes it easier for me. No. You need authorization. There are certain pedals where I'll be like, yeah, that's going to be really hard. Like if you're doing the phaser, you're probably going to need 4 layers, okay? Just because of the perfectly lining it up. It's hard for me to do it in 2 layers, and I got tons of experience. But most pedals, just 2 layers, okay? So to avoid doing it wrong, you guys with me? Just make it delete this 2 and 15, so it just says 1*16. Oops, I deleted one too many. And then it'll just be 2 layers. Unless you have authorization to do 4, don't even let yourself have the chance to do 4 on accident. Because here's what happens. You guys ready? If you accidentally pick a middle layer and then I go order a 2-layer board, guess what does not get made? The middle layer, and so that trace doesn't exist, your whole thing won't work. So in order to not accidentally do a middle layer, change it to just 2-layer. Let's go to clearance. This should be all 12. If you download the template, it's already done. But if you had to start over from scratch or you lost the board file or anything like that, there we go. Next one, again, it should 20 and 12 by default, which is great. Okay. If it's not that, same thing here. These defaults should be good. The 12 mils, the 23 mils, and so on. Those should all be good, as long as you didn't change the template. Okay, you can hit apply or check. It'll pop up with a bunch of errors that you don't need to worry about right now because we have not laid it out. Okay, and then now here's the part that is that I need to kind of walk us through a little bit. Okay, so first, if you haven't done so already, you have to pay attention to where your controls are. And to see your controls, you should click, let's go ahead and hide everything. I'm going to show the dimension, that's the outline of the board. Pads and vias, that's where things get soldered through the board. And then I want you to show bottom place and bottom origins. Okay. And then up here, do you see where it says flip board? And click flip board, and this is what your pedal would look like. So do you see my potentiometers? How many do I have? How many potentiometers do I have? I have 3. And they would go 1, 2, 3. Or, well, I guess on the video it looks backwards, so 1, 2, 3, whatever. that you could tell what it would look like. And if that's not how you want it, then we need to change it. Okay? So if I wanted to move this to the center, for example, I could right-click on this, go to its properties, and change this coordinate to the center coordinate point, which I believe is the 1.085, which is where that LED is. Okay, and I can move it straight to the center. So I'm going to do that. In fact, just for the sake of an example, 1.085. So now I have a more triangular arrangement, which might be more aesthetically pleasing for when you have 3 holes. If you have 4 holes, you should leave it exactly where the defaults are and not move them. Also, look around. If I show the top place here, if I switch this to top place, top origins, do I have potentiometers anywhere else? You guys look up on my screen. Do I have potentiometers anywhere else? No, meaning that I placed them all. I did the steps from the previous video where I put them all in the board in that layout. If you have potentiometers still somewhere else, you either have to strategically place it exactly precisely, or you need to go to the schematic and replace it with one of those ones. The other thing is, my schematic has 3 controls. It has a gain knob, comp knob, and a volume knob. That's what this is. And so I have 3 controls. Great. If your schematic has 3 controls, but you have 4 controls here, is that a problem? Yeah. There's probably something to delete somewhere. So we want to make sure that we've gone through the process to make sure our controls are right, they're in the right location, I don't have too many, and I don't have too few. Okay? Once that is done, then you can go through the process of lining things up. And it is kind of a complex process, but I wanted to show you how you can make it simpler. So I'm going to click Unrouted here. I need T origins on because that lets me grab things. I need T place on because that lets me see what kind of part it is. And I need T names on because that'll tell me, give me an indication of where it goes. Okay. Regardless of where you're at, I want you to follow along with the logic of what I'm about to do. So everyone pause on their screen, look up here. So down below is where the foot switch gets connected. There's a foot switch down here. And so this is where the input and output of my board is. So my first section and my last section will connect to the bottom. And so what I'm going to go do is I'm going to go find things. Oh, by the way, I'm going to reflip this back over. I'm going to go find things that are labeled, R11 was the first section. R12, there we go, R11. And R12. And what I'm going to do is I'm going to drag them in here and click my friend Rat's Nest, and then try to arrange this to make these yellow wires as short as possible. And this is super helpful. Do you see how I'm perfectly aligning my resistors here? The reason why I recommend doing this is it's easier to wire up the circuit board itself, and then when the circuit board is made, it's faster to solder because everything's just in a perfect neat row. So I'm just finding everything that's labeled. See, I got C11 and C12, and I think I have some more resistors too. R14, which means I have an R13 over there. Okay, gonna bring them in, hit Rat's Nest, and then try to arrange them best I can. In these like neat, short little arrangements. By the way, if you guys look up here, do you see R14, how it has 1 yellow wire coming out of it and not 2? That's because I've already pre-made a polygon for ground, so you don't have to wire your grounds. It's already in the template. Okay. And then I'm hitting Rat's Nest. And then I'm going to go to my last section, because that's also connected down here. I'm going to do the same thing. So that was R4, so there's R41. And then C41, although C41 seems to be attached up here. And I think that'll be good. Okay. And then I can keep going. So I'm not going to, through this video, show you all of that. I am going to show you this top section because this is true for everybody. So again, I'm asking you to pay attention. Here's this top section. This top section has to do with the power system, the power management system used in here. So what you're going to do is this first diode, this D3 diode, this is where power comes in. So power comes into the board right there. And so I want to arrange this fairly close by, but I don't want to like run into that other part there. So I'm going to move it slightly down here. And then this inductor is connected to that. I don't have a lot of parts on my board, so I'm just going to not worry about fitting everything super tight. Okay, and then I've got these diodes and capacitor. I'm going to hit rat's nest as I'm doing it. Okay. You can see why this is our last design, because there's a lot more free-flowing, a lot of choices along the lines. Okay, and then I've got R1 and R2, which are my virtual ground, which I will explain here in a second. And this, so I'm going to just go as quickly as I can, hitting rat's nest, lining things up for these short connections. Okay. Okay. Now, a couple of things I need you all to hear. This top potentiometer row right here. Do you guys see what I'm pointing at? This row where you solder in the top pots. You may not be able to build your pedal if you put anything super tall north of that line. You guys hear that? Because if you look in here, and it's going to be hard to see from that far away, but if you look in here in the actual things, there's jacks right here. And then there's this ribbon cable. And they don't just sit there, they have to slide into place, which means I have to pull them out. There has to be room here to be able to pull them out. And so as long as you don't put anything tall above this line, and if it helps you, just go ahead and actually make a line. You can drag in the line here, go to top place, and drag a line across if that helps you. But anything north of that line, keep anything that's relatively tall out of there. So resistors, diodes, and the inductor, all that stuff is fine because that's short. But you get into capacitor territory, unless it's a really small one. You get into, especially aluminum electrolytic, the really tall ones. Transistors, the film capacitors, the ones that are like box shape. That could be a recipe for it not fitting without us doing something really weird to modify how we build it in order to all fit in. Okay, and then there's one final thing of setup. So part of the setup here is just putting your parts in section by section, lining them up best you can. And then this is the last part about setup. You guys with me? I know there's a lot of information, but this is why it's in a video. Okay, do you see these parts labeled C5 and C9? I need everyone to lock in now. C5 and C9? These aren't just like put them randomly. They're for a very specific purpose. They're to be put near any part that requires power next to its power pin. So you have to first count up how many you need. I put in 2 by default, but some of you only need 1. And some of you need 4. Right? Like you have to count that up. So I'm going to show you where it is on the schematic. It's in the template parts that say do not delete. Do you see C5 and C9? Okay. If you only need 1, guess what you get to do with the other one? Delete it. Okay. If you need 3, you're going to have to copy another one and hook it up. So if I needed 3, I'd click here, I'd copy this, go there, and then I'd wire these up. Okay? But I actually only need 1, because if I look at my schematic, the only thing that requires power is my op amp, and it's 1 chip. It's a dual chip. So it's 1 chip, 2. If you had a transistor, that will require power. Every transistor requires its own power. Okay? If you have 2 chips, like you have a quad chip and a dual chip, well, now you're up to 2. Okay? In my example here, I only need 1. So I'm going to delete all but 1 in this schematic and just leave the 1. And because I'm a little OCD and only like neat looking schematics, I'm going to straighten that line out. Okay. Okay. Now I got this one part. Now here's where this one part goes. You have to find that part that requires power. For me, it's this chip right here. You got to place that part. So I'm going to find a good spot to place it. Oh, it looks like it's connected right there. So I'm going to go in there and line it up. Place it. So once this part is placed, now I can take this thing and I'm going to go find where it says power. So down here it says ground. Up there it says plus 9V. Do you see that? So I'm going to put it like here, or I could put it north of here. I'm going to leave a little bit of a gap, but not a very big one. And then I hit rat's nest, and now I have the short wire between this capacitor, which is a charge reservoir. It holds, if the chip needs charge quickly, it doesn't have to wait for the power supply to give it to it. It can just grab some from that. Like it's for this intermittent, quick fill. Okay. Okay. This is where I'm going to end the instructions of this video. I'm going to pause it here, and then I'm going to line everything up and then just kind of do an overview at the end of all the things we just did. But as far as like new instructions, this is the end of the new instructions. The next video, which I'll do on Thursday, will be about wiring. If you get to the place of wiring today, let's talk about it. You can go ahead and do it. But the next video will talk about the wiring. The wiring video will be the shortest. The first video was the longest. This one's the second longest. The next one will be the shortest. This is the last project because of how complex it is when you design something from scratch. Even though like the schematic part was like putting modules together, there's all these like little details that you have to add based on what you create. And so I know it's a lot of work, but in the end, this is the hardest step, is getting to the place where everything is nicely, neatly arranged, and you have as many short wires as possible. But even in mine here, there's plenty of things here that are long wires. Like I got someone that's, you know, halfway across the screen there. However, most of them are fairly short, so it should be pretty easy to wire, which is what I'll cover next time. The other thing I want you to notice on mine, and this is from literally designing hundreds and hundreds of circuit boards. I don't think I've gotten 1,000 circuit boards designed yet, but I'm probably close. Yeah, probably in that range, is look how neat it looks. All the resistors are arranged the same way, the same like vertical direction. Everything's like neatly arranged. This isn't just a help for wiring it up, which it is. It's a huge help. It's also a help for building it. Because if everything goes in one direction, I fold the legs, they don't crisscross each other. Everything here has been designed and laid out to make the entire process as smooth as possible, so it takes as little time and it's less likely to have errors. So that's just something to go for and to try to do best you can, is to make things really neat. And this is another example of why I said don't go crazy complicated. Okay, this is just the distortion module. And did I take up most of the circuit board? I did. So if you're going crazy complicated, we might have to talk about it. Here's the last thing we're going to let you know. I'm going to say this for the video. It is possible for us to make this circuit board bigger and have it not cost me more money and have it still fit into not this size case, but fairly similar, just slightly bigger. And so we can talk about that. I put this one because it fits in the most different size cases possible. But we can talk about that if you need it to be a little bigger to make it easier. Okay? All right, next time next video, next class, I'll show you the last little bits to wiring it up. But if you get here, the next step is the easiest. This is the hard step, getting here.